Welcome back to Advent of Code 2016. Last day, Christmas Day 25. Clock signal. You open the door and find yourself on the roof. The city sprawls away from you for miles and miles. There's not much time now. It's already Christmas, but you're nowhere near the North Pole. Much too far to deliver these stars to the sleigh in time. However, maybe a huge antenna up here can offer a solution. After all, the sleigh doesn't need stars exactly. It needs the timing data they provide, and you happen to have a massive signal generator right here. You connect the stars you have to your prototype computer, connect that to the antenna, and begin the transmission. Nothing happens. You call the service number printed on the side of the antenna and quickly explain the situation. I'm not sure what kind of equipment you have connected over there, he says, but you need a clock signal. You try to explain that this is a signal for a clock. No, a clock signal. Timing information so the antenna computer knows how to read the data you're sending it. An endless alternating pattern of 010101, he trails off. You ask if the antenna can handle a clock signal at the frequency you would need to use for the data from the stars. There's no way it can. The only antenna we've installed capable of that is on top of his top secret Easter Bunny installation, and you're definitely not. You hang up the phone. You've extracted the antenna's clock signal generation, a SAM-Bunny code. Oh, again, day 12. Your puzzle input. It looks mostly compatible with code you worked on just recently. Day 23. This antenna code, being a signal generator, uses one extra instruction. Out X, transmit X. Either an integer or the value of a register as the next value for the clock signal. The code takes a value via register A that describes the signal to generate, but you're not sure how it's used. You have to find the input to produce the right signal through experimentation. What is the lowest possible what is the lowest positive integer that can be used to initialize register A and cause the code to output a clock signal of 0101 repeating forever. Out X, transmit X. Either a integer or value of a register. Let's have a look at this. Okay, do we have toggling again? I hope not. Did not enjoy the toggling. Copy, increment, decrement. So we need to find some kind of loop. So it always is 0, and then it is 1, and then it is 0. And then put 1. Origins -21, okay. I guess we just have to try the options. Can I recreate this thing? Maybe I can just go back until I have my day 23 code again. No, can't go further, can I? I guess it's right there, some bunny code a third time. Okay, so we just need main, none of that. Three lines. For each line. When A0 copy we have copying this and gins. Then a new one out. Copy. And we always had x val equals get value of x given the from get value of x, which is a string. Map of card int um, if x dot too long or null. Will it work? If x dot too long or null is null, it's not null, we just return long, and we can just return it. Otherwise, you just go registers on x like this, long. I add the string, and then it's actually a character. Okay, so we get the value, and then if y val equals get value of y, and then we copy, no, I think we always copy into register y. Registers y equals x. Yeah, we just do while loop. I wrote this so often now. Line equals lines in I. Cool. Inc. Else. Okay. We want to inc x. Hmm. -1 for deck. Jump not Z. You have A1. X. I think we just do the same as we do here. Okay, we don't do anything. Okay, we have Y. Well, I don't think we want to jump. If X is not 0, then we jump. Y val. Okay, maybe that has to be. I think we just go, otherwise. Okay. Cool, we're done, I think. Then we can run this example. Test. We wanna is 42. Okay, perfect. Then we do this. And we have to implement out, which just prints something, I guess. Okay, we print 1, 1, 1, 1, and so on. How do I know if I print it forever? Output equals mutable list of int long. I just add it. And then we just say it's exactly 100. Then we just say um, 50 times okay, 1 to 100. If it zero I don't know, whatever. Should be like looking similar, right? Output Somehow output is one more. Okay. Mm-hmm. Then we do n here as well. And then print line expected was output false. Then we just put like different numbers here. That's true. We can just put all of this into a function, do it, and n. I can return this. No, oh yeah, Boolean. If I done equals true. Okay, let's do this. Printing a lot. Lowest port initialize register A. Yeah, that's what I'm trying to do. I'm initializing register A. Different numbers. Running my experiment, probably can't find it in this brute force way, but it's worth a try. No, if I need to run a test. I can't run a test. Thing is copying A to D, right? Probably have to figure out what happens and then simplify it again. Mm-hmm. We're at 6,000 now. Yeah, we try to hit 0, 1, 0, 1, 0. Ooh, I can see what happens. Well, let's continue. Oh. Ah, yeah, now I'm not printing. It's kind of nice. I like the printing. Maybe also want to see. I don't want to print. No, I think it's fine. Oh, weird. We already had 9,000. Quite fast. Maybe it wasn't that. Maybe it wasn't that far yet then. I thought I would be at. Yeah, it was somewhere there where D is 7,000. What can we do? We definitely have to look at this code. Copy A to D, copy 15 to C. 370 to B. Increase D. Decrease B. Okay, here's a simple one. Increase D, decrease B. So 170 times, we always want to increase D. So we could simplify this by yeah, and then we do a decrease C. And so we do 15 times 170. This adds 15 times 170 to D. Copy A to D. Okay. I had an idea and I forgot it. Let's check again. Copy A to D. Copy 15 to C and 170 to B. Increase D. Decrease B. So for 170 times, we increase D. Then we decrease C. And do it again. So just increase A by 15 times 170. We can just figure out what that is. This number. And then I can say PT to A, yeah. So we just increase A by, if we can just do increase. Here we've increased one only. Let's just do add and then we take X add this number this way. Here we can just do add. Here. Here it goes up again. No. This doesn't do anything. That's a cool instruction. I can use this. So I can just do add and then this. Let's see what happens. Absolutely nothing. Jump. I should just try and print this way. Okay, so I think it's working fine. Not sure if I'm actually checking faster or not. Should be. Okay, so here I decrease B twice and C. This was to decrease twice. Then I increase A once. And then I just always go up. 1, 2, 3, 4, 6, 7. Then I decrease B twice, increase A once. till B is gone. Basically, I just half A. Until B, and B is gone, and then I jump 6. 2, 3, 4, 5. So I just half it. Copy A to B, 0 to A. So I just half A. So I could just half it. And add a few more of these. Then I do this. Copy to B. C is 0. So I jump 4 for 1, 2, 3, 4. And I out B. And I out a 2 then. 2 to B. No, C. No, C must be cleaned up. Jump 4. Then it's maybe gone. And then I increase A. -7. 2 to C. And then maybe B is 0. Okay, at that point 2 is in C. And you would leave 2 in C. Like this. Here, jump forward. 2 to B. Jump not 0. C2. Yeah, decrease B here and then decrease C. And I jump to -4, 1, 2, 4. And C is 1. And B is 1. I jump here and here. So I could just do this. So if A is not 0, oh wait, this at the beginning do I How do I enter 0 then? How does that work? Hmm. Maybe let's check everything again. C is definitely no. E, copy D to A. Oh, but I leave the alone, but also no one cares about D in the end. So yeah, D is only used here. Copy D to A. Copy A to D. Do stuff and then copy D to A. And then yeah, so we can definitely have other stuff here. Add actually I'm interested what happened to yes. Decrease B, decrease C. Yeah, if C is 0 and B is 0, we get here. Then we're fine. Okay, we know we can add. Then we copy A to B. Let's start again with 25K. See if it's faster. A bit. Also has different results. It's not good. Increase D, decrease B. Increase D. And correct. Oh no, what have I do? That's not it's still there. That's just just that. Hmm. That's, yeah. What was there before? Okay, I can see that's today. Interesting. I should leave this in maybe. Okay. 2026. Weird. Okay. Yeah, wait a minute. Yeah, maybe weird. Also, yes. Yeah. Okay, so the problem is that we copy A to D, then do operations on D, and then we copy D to A. So we increase D in the original one. So if I fix it in this way and leave it like that, that this instruction stays, I need to make sure that when I copy D to A, I don't lose the progress I made on A. So what I can do is add the register A increase and also the D increase. Then I should be able to do the following. The halving stuff as well. Let's try it real quick. No, I have to have a look at that. Do we decrease A? I think that's weird that it doesn't end. Yeah, now it ends. I wonder if we did that run with 100. Mm. Okay, this will fail. Started 180. Then we can check the result. Normal code. Yeah, same. 180. There we go. We were already there. We just had an issue here where expected equals to output didn't validate true, but if I just make it a string, then they're better comparable. Dude, the antenna is ready. All you need is 50 stars. Okay, let's do the explanation first. So basically, we do a SumBunny again, and a new step out, which just sets a value to an output list. And at the end, after the output has reached a certain size, we're looking for something that goes on forever. Just call it a stop here after a few iterations of outputting something. And I make my expected list 0, 1, 0, 1, 0, 1. And I check if they're equal. So if the expected 0, 1, 0, 1, 0, 1 as a string is equal to the thing that I emitted in the out 0, 1, 0, 1, 0, 1 and comes on the string, then we can assume that it goes on for a while, that it will go on forever. Always output 0, 1, 0, 1. Did some optimizations here in the code where this first part just 15 times 170 and adds it to A, but not really needed. That's low to that over here. Value to the registers A and D because A and D are also copied into each other. So I just added both. And then that lets the program run a bit fast. Okay. That's it for part A and part B. Look towards the sky integration, suddenly noticing that a lone star has been installed at the top of the antenna. Only 49 more to go. And then we already have enough stars here. So now we can transmit the signal. And that's it. And just know, you activate all 50 stars, transmit the signal. The star atop the antenna begins to glow. Suddenly you see the sleigh fly past you. It looks like Santa was already waiting for your signal. Congratulations, we finished every puzzle of Advent of Code 2016. So that's it for Advent of Code 2016. Enjoy the rest of your day.